Good morning everyone. I am Renu Sharma, Assistant Professor, EC Department, Ajay Kumar Kark Engineering College, Ghaziabad. Today I am going to start with the next part of this subject, that is data communication network. The topic of today's lecture is control frames. This is in continuation with the previous lecture that we have discussed. So, the contents of this lecture are control frame, addressing and Bluetooth. So, control frame, as we have discussed in the previous lecture also, that is been based on IEEE 802.11 standard. In that we have discussed that this standard is basically lies on two layers, that is the physical layer and the data link layer. So, this is going to use these two layers of the ISO OSI model, that is IEEE 802.11. Then corresponding to that, a particular frame has been established, so that each frame is having different fields for the purpose of transmission and reception, and it will going to transmit the data. So, that is consisting of this control frames. Then addressing, we will see how the addressing will be done of the physical devices that is connected at the transmitter and the receiver side. And thirdly, we will see what is a Bluetooth, what is the technology that has been used behind Bluetooth. Now, this is the control frame. This is a frame that is known as request to send. R means request, T means to, and then this is request to send. This is clear to send, or it is acknowledgement. So, these two frames are being used as a control frame. So, this is using information, like this is using 2 bytes of information, that is denoted by FC, 2 bytes of information, that is nothing, it is data. Then 6 byte of information is there, that is using the information, that is address 1. 6 bytes of information is using that is using address 2. Then FCS is nothing, it is the frame check sequence. Now, as we know that what is 2 byte means 16 bits of information, that is used as a FC information. Data is again 16 bits of information, then address 1 and address 2. And what is the difference between this RTS and CTS frame? As you closely you can visualize this difference, that this is using only address 1 of the data, it is not using address 1 and address 2 as compared to the RTS information. And secondly, this CTS can also be used as an acknowledgement frame also, that has been transmitted from the receiver to the transmitter side in the back direction, if it is positive acknowledgement. These are the values of the subfields in the control frame. As you can see, if the subtype is used as 1011, then it means it is RTS frame, that is request to send. If this value that is been used is 1100, then it means it is clear to send frame. If it is 1101, then that means it is acknowledgement frame, that is transmitting the acknowledgement between the transmitter and receiver. So, these are the values of the subfields in the control frame that has been used over here. Now, next is addresses. So, there are different types of addresses, you can see over here, that if it is these are basically the fields in the MAC frame. In that case, to DS is one of the field, from DS is field, address 1, address 2, address 3 and 4. So, these are the different fields that are being used over here. So, this is 2 DS, if it is set to 0, means there are 4 different options are there, that is 00, 01, 10, 11. If we are considering 2 bits, then the combination which is possible with 2 bits are 4 different types of information. If it is 00, then the address 1 will be of the destination address, this is of the source address. Address 3 will be the basic service set, this is not the extended service set, this is the basic service set, and it is not written over here that whether it is with AP or whether it is without AP. that is the access point, you can use any of it, then BSS ID has to be used, and this is address 4 which is not applicable over here. Now, next is 01. In this case, that is 01, this is destination address, this is sending AP, which means sending access point is there, then this is the source and this is again not applicable. Then again we are using the address, that is 10, it is the receiving AP, that is it is receiving one, this is source address, this is destination address, and again this is not applicable case. Then next thirdly we are fourthly that we are using, it is 1 1, that to DS is 1, from DS it is 1, then this is the receiving AP, this is that is receiving access point, this is sending access point, this is the destination address, and this is the source address which is been written over here. So, this is the case for address condition. So, these are the different set of options you can say, or the variations depending on the value of to DS and from DS, whether it is 0 0, whether the combination is 0 1, whether the combination is 1 0, whether the combination is 1 1. Now, next is addressing mechanism, that you can see over here. This is the case 1, that whenever it is 0 0, this is case 2 0 1, this is 1 0, and this is 1 1 case. Now, in case of 0 0, this is the basic service set which has been connected over here at P point. This is the A. The frame will be transmitted from A to B. This is containing the destination address, this is containing the source address, this is BSS ID, and this is basically not applicable, which has been, you can see over here in this diagram, in this table. Same is being shown by this diagram. Case 2 is 0 1. In this case, the frame is again transmitted using this access point. This is BSS, means one of the computer is present in one BSS, another is computer is present in another BSS, that is the basic service set. This computer is present A over here, this is present in B. So, it is transmitted using this access point, that is B point, this is access point, this is the source, this is the destination address, this is the source address, this is the access point, and this is again it is non applicable case. Now, this is case 3, which is again this is BSS, this is BSS, this is the transmitter side, this is the receiver side. The data will be transmitted in this direction, that is 1 2 3 4, means it is transmitted. This is the access point which has been shown over here, this is A and this is B, this is again it is non applicable case. Then this is case 4 again, which is wireless distribution set, which has been shown over here. This is the transmitter computer which is being present in this BSS, which is having its own access point, that is denoted by AP1. Then in this case the computer B is present another basic service set which is using their own access point, that is denoted by AP2. Now, you can see that how this frame has been formed. This is the destination access point, this is the source access point, this is destination address, this is source address. So, all the 4 informations are present in this frame, and this has been connected through this wireless distribution system. And in both the cases, that is the case 2 and case 3, this is connected through a distribution system, means you can also say that it is a kind of extended service set. So, that is the case of addressing mechanism. Now, this is the variation which is shown in form of diagram. Now, next is some of the problems are there if one computer is present in one particular area, that is the basic service set, and another computer is present in another basic service set unit, that is the BSS, and both want to exchange their information. So, in that case, that is known as the hidden station problem. What does it mean? B and C are hidden from each other with respect to A. Now, you can see that this computer is present, this system is present in B system is present in this cell, C is present in this cell, and A is in common with both. Now, this is the range of B, this is the range of C. So, since A system is present between B and C. So, B cannot directly see what is C, cannot visualize that what this system is particularly doing, and B cannot directly visualize that this particular system is doing. So, this is the range of B, this is the range of C which is being written over here. So, this is basically the hidden station problem is shown over here. So, one system is hidden from the another system. So, and this has been hidden from each other with respect to system A. So, this is the hidden station problem. Now, next is use of handshaking to prevent the hidden station problem. Now, what is handshaking? Before I will begin with this concept, first we will see what is handshaking. Handshaking, if in common layman language, if two people meet for the first time or any time if they meet, then they used to handshake their hand, means they are going to greet themselves before doing any sort of communication. So, that is a kind of hi hello sort of thing. So, that is a case for handshaking. So, handshaking is also done in this communication system also to prevent the hidden station problem. So, the CTS frame in CSMA CA, that is the carrier sense multiple access collision avoidance, is done. Handshake can prevent collision from a hidden station. Now, you can see over here that this is station C, this is station A and this is station B. What is the problem? Hidden station. B and C are cannot see each other with respect to the station A. So, how this handshaking will be done? Now, this computer that which is present at the station B, it will going to send a request, that is request to send to this particular computer that is been shown over here, that is system A. Then this system will going to transmit the clear to send data to this one and clear to send data to this one also, which means there is a handshake that has been established between B and C, and there is no such situation will arise where station B and C are hidden from each other with respect to the station A, because station A will going to transmit the equal information, that is clear to send to both station B and C correctly. So, that is the case for handshaking. In this is the situation where handshaking has been taken place, because it will station A has equally transmitted the frame clear to send to station B and C, means it is equally seeing station B and C. So, that is no more they are hidden from station A with respect to station A. Now, next is the exposed station problem, that is the second kind of problem that has been arise in case of this situation BSS and ESS. You can see over here that this system is present over here, that is having this range which is denoted by this blue color. Then this is using this range C, that is these computer is present in D. Then this is A and C computers are also present over here. This is C exposed to transmission from A to B. So, the basically what it is doing, C is exposed to transmission from A to B. So, whatever transmission is done from A to B, C can easily see, can easily visualize that what A station has transmitted to B. How it is possible? Because the cell of A and C are same. So, that is the case for exposed station problem. So, there is a third party condition which is being there, because C is the third party, because the basic transmission or the initial transmission is performed between station A and B, and C can easily visualize that what has been transmitted between A and B. So, this is the exposed station problem. Now, next is use of handshaking in the exposed station problem. So, how the handshaking is being done to resolve this problem? As you can see that there are 4 stations are connected as per the previous diagram, like station B, station A, C and D. So, 4 stations are there. A request to send information will be sent from A and from A to B and C equally. Then clear to send will be sent from this B to A, and the data will be transmitted from A to B and A to C. Now, this will going to see the data because it is present in the same cell as compared to the A station. This will going to transmit this request to send information, and here the collision will take place. So, exposed to A's transmission, this C is basically going to see that what has transmitted from this A to B. So, that is the case for exposed station problem. So, this is the axis which is written over here. This is station D, as you can see that this will going to transmit this request to send, and this will going to transmit that clear to send information. So, that is the case for use of handshaking in the exposed station problem. Now, next is ISM band. ISM band is nothing, it is the combination of three types of band that has been used over here. I means it is used for industry, S means it is used for social purpose, M means it is used for medical purpose. So, industry, social and medical. So, these three are the different fields in which this particular frequency band is divided. Like in case of this industry band, if you can see over here, this is the industry band which is using this 902 megahertz to 928 megahertz of information. So, that this is the range of frequency that has been used for the purpose of transmission. Its bandwidth, if you are going to subtract the upper frequency range from the lower frequency range, then its bandwidth will be 26 megahertz. So, that is been corresponding to the industrial operation. Now, next if we move to the social purpose, social bandwidth band that has been allocated, that is been ranging from 2.4 gigahertz to 2.4835 gigahertz, and the bandwidth that has been allocated for this particular application is 83.5 megahertz of bandwidth it is requiring. Now, next is 5.725 gigahertz to 5.850 gigahertz of frequency range. So, which means it has been allocating this 125 megahertz of the bandwidth. This is allocating this much of the bandwidth for the purpose of transmission. Now, you can see easily from this diagram that in case of this ISM band, if you see the variation, that higher frequency range is allocated for this medical operation, and less than that it is used for the social application, and also lesser to it for the purpose of industrial applications. 26 megahertz of bandwidth is allocated, because medical if we are talking about this medical application, it requires higher frequency range, and because most of the equipments that we are using, if we are talking about the telepathy, if we are talking about the services that has to be provided in remote areas, then in that cases in the, because comparison with all the three applications, medical application has a higher weightage. So, for that purpose higher frequency set of frequencies has been required. So, that is the case for medical purpose. Now, next we will move to what is Bluetooth. Bluetooth is nothing, it is a application of IEEE 802.11 standard, is a wireless LAN technology designed to connect devices of different functions such as telephone, notebooks, computers, cameras, printer, coffee makers, etc. and so on. So, this is basically Bluetooth is a kind of technology that is wireless in nature, first thing. Secondly, it covers a specific range of operation, means you cannot connect Bluetooth devices in hundreds of kilometers. It is in 100-meter range, maximum range of Bluetooth is 100-meter range, and also the connectivity will be less in cases if we move from one room to another room, because from one wall to another wall the signal cannot easily accommodate the connectivity. The connectivity is quite less if we move from one room to another room. If you are sitting in a single room, then the connectivity will be quite high. So, this is a situation of Bluetooth. Bluetooth is basically a wireless technology, and this is a LAN technology, and also it can be used for different applications like for coffee making machines, then other applications like you can connect different computers through this Wi-Fi. You can take printout from your mobile phone to a printer that is connected through a Bluetooth. So, these are some of the applications that has been accomplished by this Bluetooth. Now, Bluetooth LAN is an ad hoc network, which means it is BSS without a AP. Which means in a single station more than one, in a single area more than one stations are connected over here, like this is the first station, this is the second station, this is the third station, this is the fourth station, and there is no access, intermediate access point is there between the transmitter and receiver. So, these are the different stations which are present in a particular area. So, this means it is the BSS without AP. So, this is a kind of ad hoc network, which means that the network is formed spontaneously, which it means that it is not fixed, it is wireless. Any device you want to connect, you can connect spontaneously. There is no previous connection is required. It's only it has to detect that Bluetooth connection is available in that particular device or not. It has to be active. This is the explanation of Bluetooth, how this it will work at different layers. So, this is the radio layer, radio frequency range layer, this is the baseband layer, this is L2CAP layer, this is the data layer, means it will it is used to transmit the data. Then profiles, different profiles are available at this particular point of time. Then this is control bit, this is again the audio connection which has been set up between the baseband layer and the application. So, why we consider this application? Application means this Bluetooth device can be used to connect one device, it can be used to another connect another device also. So, that is the case for Bluetooth connectivity. So, you can see over here that how this will going to work over different layers. Now, next is the single secondary communication. So, there are two types of communication which are possible. First one is the single secondary, second one is the multiple secondary communication. So, in case of the single secondary communication, you can see over here that only one secondary computer is present over here and only one primary computer is present over here. So, one primary and one secondary devices are connected. This is using a frequency that is denoted by f naught, this is using a frequency denoted by f1, this is using f2, this is using f3. So, 4 set of frequencies are being shown over here, that is denoted by f naught, f1, f2 and f3. These are using the frame range and it is using this hop range, because sometimes it is possible that this particular frame that you have already sent, it has not received in this frequency range, it can extend due to the addition of noise also. So, for that case this hop operation has been used, hop has been inserted between the transmitter and receiver, between the primary and the secondary device. So, that is why this time has increased from 366 to 625 millisecond. Same is the case for this case when secondary wants to transmit the data, then when primary wants to send the data and secondary wants to send the data. So, in all the cases between the single secondary communication, a hop band is inserted after the initial band. So, the time required has increased from 366 millisecond to 625 millisecond. Now, next if you can see in this diagram, that is the multiple secondary communication, that is a variation of single secondary communication. You can see over here, let us say I will take an example again, this is 366 millisecond and this has increased to 625 millisecond over here. So, this is the case for primary, there is one primary and more than one secondary computers are connected over here. After the completion of this one primary, the secondary the data has to be transmitted to the secondary unit and it has a hop cycle has been inserted after this particular frame. So, it has increased the second again from 366 to 625 millisecond. Then the data can be transmitted to first one. You can directly access this secondary to with the primary. There is no intermediate condition is required. So, it has directly transmitted from this side to this side. So, this is the case for multiple secondary communication. So, this is about Bluetooth. Bluetooth is nothing, it is a wireless LAN technology. Any device which has an access with wireless condition, it can be used to transmit the data with this Bluetooth technology, and it can be used to cover a longer distance. So, these are the references that you can consider. So, in this lecture we have discussed about different types of addressing techniques, control frames we have discussed, and we have discussed about Bluetooth technology, and in Bluetooth also we have discussed about single secondary communication and multiple secondary communication when where more than one computers are connected in a particular primary device. So, this is the case for these particular conditions. Thank you.